And they're going to ask for, most of the time they're going to ask for all solutions. Sometimes they'll ask for a number of specific solutions. Sometimes they'll just ask for the solutions between 0 and 2 pi, or 0 and 360. But like I said, most of the time they're going to ask for all solutions. So what we're looking for here is we're trying to figure out what theta can be to make this equation, got that equal sign, to make this equation true. So the first thing I'm going to be thinking about is the fact that the sine of this angle is going to be negative. So I'm going to go ahead and think, what quadrants are these angles going to come from? Well, if the sine is coming out of the first or second quadrant, I know that that's positive. So in order for it to be negative, I've got to be coming out of quadrant 3 or quadrant 4. Alright, so that's the first thing I'm thinking about. Then the other thing I'm thinking about is the sine of what angle is the square root of 2 over 2. Because I know if I can find its reference angle, then I'm going to use that reference angle to figure out what my angle coming out of quadrant 3 is and what my angle coming out of quadrant 4 is. So if I'm just thinking through this, and this goes back to your chart, the sine of what angle is the square root of 2 over 2? Well, that's 45 degrees. So I know my reference angle is 45 degrees, but I want my angle coming out of quadrant 3. Well, to find the angle coming out of quadrant 3 whose reference angle is 45 degrees, you're just going to add 180 plus 45. So one of my solutions is going to be 225 degrees. Alright? Now this asks for all solutions, so let's just think about what that means. Alright, if I know that one of my solutions is 225 degrees, let's go all the way around there. Alright, I'm starting in standard position. I went all the way around to 225 degrees. Alright, where would I find another solution? Well, if I take a full rotation and go back, I'm right there. Remember, we studied that in the very first section, I think, when we talked about coterminal angles. Coterminal angle is terminal side, they share terminal sides. So if I take a 360 degree circle, I'm right back there, which means all cycles, all rotations of 360 degrees are going to land me right there. And that n, I just throw in to represent an integer. I think your book uses a k, but I use an n. So that just means I could let it be 0, and then I would get 225 degrees. I could let it be 1, which would be 1 rotation. Let it be 2, infinitely many of times. Alright, so this is going to give me all my solutions. Well, this is all the solutions for my angle coming out of quadrant 3. What about quadrant 4? For quadrant 4, my angle is going to be 360 minus 45, which is 315 degrees. And then if I want all solutions, I'm going to do the same thing. I'm going to add 360 times an integer. And that's going to give me all the solutions to that equation. Now, if you want to write this in radians, remember just to convert it to radians. So 225 degrees is actually 5 pi over 4. And 360, remember, is 2 pi times n. 315 degrees is 7 pi over 4 plus 2 pi times n. So either way you write it, I don't care, whatever's easier for you. And that is the solution, all solutions to that equation. Alright, so the next one is the cosine of theta equals the square root of 3 over 2. So let's just go through the same thought process that we just did. If I need my value to be positive, that means I'm looking at quadrant 1, and cosine is positive in quadrant 4. So I'm looking at quadrants 1 and 4 to get my angles. Alright, the reference angle, or from quadrant 1, I know that the cosine of 30 degrees is the square root of 3 over 2. And if I want all solutions, I'm just adding that 360 in, that number of rotations. Alright, in quadrant 4, my angle is going to be 360 minus 30, or 330 degrees, plus 360 in. Alright, and we know this is pi over 6 plus 2 pi n. This is 11 pi over 6 plus 2 pi n. Alright, so that's written in radians. Alright, so let's just keep going here. I've I've got the tangent of theta equals 1. So you might be saying, why is she doing all these problems? Well, tangent's a little bit different. I know that the tangent of 45 degrees equals 1. Alright, so let's just think about that. Actually, let's do it the same way we did those other ones. Tangent is positive in quadrants 1 and quadrant 3. Alright, so let's think about this. The tangent of 45 degrees is 1. That goes back to your isosceles 45, 45, 90 degree triangle, or your chart, or whatever you learned in order to find these exact values. So I'm looking at 45 degrees. Alright, now if I want all solutions, let's just think about this. Alright, we know that I've got an angle coming out of quadrant 1. I've also got an angle coming out of quadrant 3. Alright, because tangent is positive in quadrant 1 and it's positive in quadrant 3. So both of these angles. Well, if you look at that, you'll see that in order for me to get all solutions, all I have to do is add 180 degrees. So if I'm at 45 degrees and I add 180 degrees, I'm right there. If I add 180 degrees, I'm back to where I started from, and the cycle just continues. Alright, so that's one way to think about it. The other way to think about it is, you know the period for tangent. The period for sine and cosine is 360 degrees. The period for tangent is 180 degrees. So if I add 180 degrees times my integer, that's going to give me all my solutions. Okay. Cosine theta equals 1/2. This particular problem wouldn't be any different than what we've just been doing, except it asks for 6 specific solutions. So I'm going to go ahead and find the 6 specific solutions. I'm still walking through this and going, alright, I'm looking at quadrants 1 and quadrants 4 because that's where cosine's positive. I know that the cosine of 60 degrees is 1/2. So that's going to be, this would actually be all solutions. In quadrant 4, it would be 360 minus 60, or 300 degrees plus 360. Alright, so this is all solutions, and this is not what this question asks for. This question asks for 6 specific solutions. So at this point, all you need to do is plug in integers for n and figure out what they are. For example, if I plugged in 0, I would get 60 plus 0, which is 60 degrees. So there's one solution. If I plugged into this equation, I would get 300 plus 0. So there's another solution. If I plug in 1 for n, I get 60 plus 360, which is 420 degrees. If I plug in 1 here, I get 660. And I can keep going. And it doesn't have to be positive. I could plug in a -1. I could plug in any integer. Any integer works for that. Alright, and then you just find the number of solutions it is asking for. Alright, 26. The only thing different in 26 than what we've been doing is it's 2 steps. So the first thing I'm going to do is isolate my sine of theta, just like you would isolate any variable or any unknown that you were looking for. So I know that the sine of theta is going to equal -1, and I always have to draw this out. So if I'm looking at the sine, where the sine of theta is -1, remember that my sine value is my y value, so that's 0, -1. There is where the sine of theta is -1, and that theta in this case is 270 degrees. And if I want all solutions, I'm just adding 360 times my integer, and we can write that in radians as well.